Hello, everyone. My name is Hannah Jennings, and I am a community organizer at Tech in Motion. I'm thrilled to welcome you all to today's webinar. For those of you who have been involved in our community for a while now, you know that over 10 years ago, Tech in Motion was founded by staffing and recruiting firm Motion Recruitment, with a mission centered around bringing together the tech community to connect, learn, innovate, and discuss today's hottest IT topics. Our community is constantly on the lookout for new event topics, passionate speakers, expert contributors, and more. So check out the link in the chat if you'd like to explore more ways to get involved following today's conversation. Today, we are so excited to dive into a critical conversation on balancing technical innovation and environmental responsibility. We are honored to be joined by experts in sustainable tech who will share their own thoughts as well as research-driven insights on the top challenges our environment is facing and how tech leaders like you can be part of the solution. So now, without further delay, I am pleased to introduce you to our host for today, Lucas Finco. We'll welcome Lucas to the stage. Lucas has a long history as a leader in clean tech and artificial intelligence. He has long worked at the interface of data analysts and the energy industry. He previously worked as the manager of analytics at Con Ed, as a principal data scientist at Honeywell, and as the host of the podcast Pirates of Clean Tech. He currently teaches the Clean Start program at NYU and works as a consultant and advisor. So welcome, Lucas. I will let you take the conversation from here.
Sorry, Lucas, I think your microphone got muted.
Yep.
There you go.
Hello. Welcome. Okay, I'm here now. Welcome to our Fireside chat on the intersection of IT and sustainability. We have some great experts on our small panel here, and we're going to have hopefully a relaxed, open conversation about some difficult and challenging issues and challenges that startups and innovative people are trying to tackle today. So it should be a very good talk. I'd like to introduce my two panelists. First, I'll start with Anthony DeOrsey, who's the research manager at Cleantech Group. And I think Anthony's going to introduce himself.
Yeah, very nice to meet you, Lucas. As you said, some challenging topics today, some topics around very difficult challenges, but what I hope we'll leave you with today is that we are collectively up to the challenge. It will hopefully leave you with some great examples of innovators ready to take it on. But before I get ahead of myself, a little bit of background on Cleantech Group, who we are and what we do. Cleantech Group is the leading authority on sustainable innovation. We've been around since 2002. We actually own the trademark to the word clean tech, believe it or not. And what we attempt to do is we deliver insights on the trends in sustainable innovation and how they potentially can impact the corporate sector, governments, and investors. And we deliver this in a few ways. We are, at our core, a research-driven company. We have a number of research services that are delivered through an online subscription platform, through bespoke research consulting projects, and then also through a series of events, the Clean Tech Forums. We have one in California every year, one in Singapore every year, and one in a different city in Europe every year. This year it will be in November in Chantilly, France. No chance I've pronounced that correctly, but that is where it will be. So really what we attempt to do is look at clean tech through a very wide aperture. We look at it through the lenses of energy and power, which will be our focus today. But we also look at materials and chemicals, resources and environmental management, waste and recycling, transportation and logistics, agriculture and food. So we really attempt to look at all the areas where sustainable innovation is going to impact the market. Keep the background on me very tight. My name's Anthony. I manage the research team at Cleantech Group, where we have an excellent team of analysts who focus on all of the sectors that I just mentioned. My background, I spent a few years living and working in China, where I really saw some of the sustainability challenges head on. Worked in a startup and then in a market entry consulting firm, and then spent a few years going back and forth between the US and China in a bit of a venture capital startup acceleration capacity before coming over to Cleantech Group. And Cleantech Group, I think the best part of the job is working with talented, driven people like Zainab, who are really ready to make a dent in the world. And I'm going to pass the mic over to you, Zainab, to say a quick hello.
Yeah, great. So I think my mic's on. So my name is Zainab Gilani. I'm a research associate I work with the energy and power team at Cleantech Group. So I've been researching topics and things like long duration energy storage, batteries, fusion and fission, home electrification, and more recently grid resiliency, which we'll be happy to get into today. And prior to that, I've worked in different fields, including the circular economy sector. And my background from school is in physics and English. I feel like that's been helping me really communicate some of the the technical aspects of the work that we've been seeing. So yeah, happy to be here today.
Cool. Well, really good to have both of you for kind of a relaxed fireside chat talk about some really important issues. I think I wanted to start with electrification, which is a big trend that's kind of sneaking up on us. I don't think a lot of people know about it yet, but they will soon. Can we talk a little bit about electrification and what's the big deal here?
Yeah, well, that's a big topic. I think maybe we'll start at some of the higher level, more timely type of things. You've probably seen some information in the media in recent weeks around energy demand and specifically electricity demand here in the US. And part of that is because the Energy Information Administration just revised their forecasts on electricity demand here in the US. And this is significant for a few reasons is past 2 decades or so, you've seen relatively flat or mostly flat demand. What's happened is that, of course, there's a growth in population, more devices rolling out, but energy efficiency and better technologies, devices with better, say, battery density or LED lights, et cetera, more or less offset most of that the past few decades. Now you've got a dynamic where, Lucas, as you just referenced, there's going to be large scale electrification. Homes are electrifying more. You're going to see much more industrial electrification. And also, there's a topic we're going to spend a bit of time on today, which is data centers. And this was really the underpinning factor that led to the EIA revising their estimates, is that they had to go back and revise their commercial energy demand estimates. And there's a few things that surprised everybody. But at risk of getting ahead of myself, I'll pause there.
Yeah, Zainab, did you have any thoughts there on drivers of electrification in the future? Maybe some sneaky ones that people didn't know about?
Yeah, I think that kind of ties into the home electrification aspect. So Anthony mentioned commercial use, and also just the trends related to EVs. But when we think about homes, we don't necessarily think about how much energy and electricity that they use. So I have some statistics that we can share. So the residential sector accounts for around 30% of global natural gas consumption and around 20% of global electricity consumption, as cited by the IEA. And when we think about the US, roughly 1/6 of total greenhouse gas emissions are related to residential energy use, given the strong reliance on natural gas. But we're seeing things like solutions like heat pumps gain popularity. So when you look at things like the Inflation Reduction Act and the gradual reduction of costs for these types of solutions, we're really seeing an increase in these types of technologies and solutions in this space.
Yeah, I just saw a new projection. I don't know if I believe it, but I saw it yesterday. I forget the source, but they predicted data center electricity demand to outstrip all other forms of electricity demand in the next 10 years, which just seems like mind-boggling to me, the amount of electricity. And then you think about how much we would need if we were even half EVs, the amount of energy that would need to go through the electricity grid is just massive. So this move towards electrification is huge.
Lucas, I might
The
tack
one
on
thing
a
I'd
few
like
points that,
go
okay,
ahead.
sorry. I'm just going to tack on a few points is that, there's increasingly, there's bleed over in these spaces. So we would traditionally not think of residential energy demand and transportation as overlapping very much. But you're going to see a dynamic in the US where when EVs are rolled out at scale, many of these are going to be charged at home because people typically in the US, they don't travel very far to work. So you're going to have, say, I think the average trip to work is 9 miles. The average distance driven by an American every day is about 40 miles. So you're not going to necessarily have these situations where people are constantly needing to quote unquote refuel on the road. Well, that's going to happen at home. And that goes to Zainab's point, where that's going to be compounded by things like heat pumps, where people are switching from a fossil source over to an electrified source. And I also think that the narrative on EVs is important to get aligned on. Of course, some of the companies missed their projected sales a few months ago, but if you look at the aggregate numbers rolling out, they're still significant and they're still larger than they have been in the past. I just read the report from Argonne National Lab, and it said that there were 1.4 million plug-in vehicles sold in 2023. That's counting battery electric and plug-in hybrid. That was a 50% increase from 2022. And in just May, you saw a little bit of an increase from May in 2023. So overall, the amount of these EVs getting onto the road is significant, and it's going to have an impact through public charging at home. You're going to certainly see a much bigger source of demand from those. And the data centers, I won't get ahead of myself here. I don't have much of a comment on your statistic there, but this was actually in the deep in the paragraphs of the EIA's revised estimate a few weeks ago, was that it's going to be data centers that were the unpredicted demand load in the previous estimates. And the interesting thing here is it's going to increase demand in pockets. So the Southeast US, the Southern Midwest, it's not going to be a spread out amount of demand in coming years. It's going to be really concentrated.
Yeah, I just saw one announced for Northern Indiana, and they mentioned a lot of these things. Can I get power? Things like that. Is it reliable? Yeah. Very interesting. Well, the data center one is an interesting one because that's kind of getting at our intersection of IT and sustainability. So, yeah, can we get can we get more into that because it's demand, it's energy, it's reliability, there's all these aspects to it. It's not just like, oh, we need some energy here for this thing. I don't know, Anthony, did you want to get into some more details on that?
Yeah, and I'm even going to take a little bit of a step back, is that we're at this inflection point where there's an increase in demand, but there's challenges of getting clean supply onto the grid. So with all of the enthusiasm and the initiative to go roll out more renewables in recent years, especially in 2023, that grid interconnection backlog increased by 30%. So now if you look at the statistics, there's 2.6, I believe, terawatts of queue, that's grid interconnection queue for new generating resources. And right now there's only about 1.3 terawatts on the grid. Part of the reason that queue is so big is because much of the renewables are rolling out with storage, and you're counting those gigawatts of renewable generation and storage separately. But again, this queue is enormous. So you've got a dynamic where we're waiting for more clean electrons to come onto the grid, but also your demand needs to get connected, and you're seeing a situation where you're going to need a probably transmission distribution upgrade at that site of the data center. And this is just in the US. I was talking to somebody last week in Asia who said, well, the renewables aren't going to catch up. So we're still going to be deploying data centers. We've got to drive down the energy demand in data centers. And one of the first areas I might point to, Lucas, is going to be cooling in data centers. That can be up to 40% of the energy demand inside of the data center. And we're in a really interesting time where you're seeing some of the cooling technologies really take a leap. One that I would point to is, of course, immersion cooling. This is the idea that instead of air cooling, running a really high-powered HVAC in the data center, you're dunking the servers into some kind of non-conductive liquid that doesn't damage them, transfers the heat off. Won't get too much into the weeds, but I will drop a few examples into the chat. You've got a few different approaches here. You've got something called single phase, which is basically a non-conductive oil, transfers the heat away. That's going to get put through a heat exchanger to closed loop water. Then you've got a more evaporative approach called two-phase cooling, where it's the phase change that's going to release heat and transfer it. And then there's something else called direct to chip, which is you're essentially bringing water and piping it onto a chip directly and cooling the chips right at the source. And what I think is interesting here is that although these technologies are accelerating, you're starting to see an ecosystem form around them. There's a really interesting company, I'll drop this link in the chat again, called Sustainable Metal Cloud in Singapore. And what they're doing is essentially they are offering low carbon cloud computing. They are saying we're going to modify GPUs from NVIDIA, get them immersion ready, and we're just going to run immersed clouds. so that you, if you are deploying something onto a data center that they're running or where their technology is, you are able to avoid that increase in carbon footprint off the bat. So it's a young company, but to me, taking into account many different adjacencies. They've got partnerships at the chip level. They've got partnerships in immersion cooling that are allowing them to make this low carbon computing more of a reality. So I'll take a pause there, and I will be dropping a few of these in the chat just so the audience can go and do a little bit of additional research.
Well, I'm wondering too if we have any software engineers in the audience or coders, is there something coders can do on this? I mean, I tend to think there is, but what do you think?
Yeah, it's a good question, and it's something that Zainab is going to be taking a little bit of a look at in the coming months. We're going to do a reboot on some of our data center efficiency and sustainability research, and low carbon computing hardware is going to be one of those elements. But the coding side, I don't have a clear answer to that. I think it's something that is going to be a little bit more partnership selection. So, right now when you're going and selecting storage where you run your applications, you do have some choice in regions. Now you see services like Sustainable Metal Cloud, again, a young company, but where you're having the opportunity to have the right partnerships so that you're running in a low carbon way. I think that might take some of the pressure off of developers themselves to be coding in a certain way.
Yeah, I always bring up the example of AMD cracked into the data center market by offering a lower power per compute chip. And so that moved some of that concern onto the hardware and off of the software. And now I can just write code as I want. So I'm really curious to see if there will be a kind of sustainable or efficient coding movement to try and push these energy considerations into the coding. Like the one example I give is there's this philosophy now that we can make GPT better by making it larger and larger and larger, and that maybe AGI will just emerge. And that to me would be the antithesis of efficient coding, thinking about conserving energy. Maybe we're only going to get marginal gains with large energy uses. So maybe we should be thinking about that a little more. Yeah, that's just my thoughts. I don't know if you had any more to offer.
I think that's spot on. The GPT, and I'll drop another link in the chat. There was a study done where some companies testing the training essentially said, well, this can be up to 1,000 times more energy intensive than running a traditional natural language processing model. So the training is obviously, it's much wider data sets. It's a lot more resource intensive. So absolutely, as folks start to work on these more generative models, the energy consumption aspect of it has to be considered, and water consumption too. There's a lot of liquid cooling today, and that does require a high water content in order to keep these things cool.
Yeah, agreed. Yeah, before I flip this discussion on its head, maybe we can talk a little bit about scope one, scope two kind of issues. I've always been a big proponent of scope one. For instance, you should, not be burning fossil fuels in your own building, and less of a proponent of scope two and three. You don't have to worry about your neighbors if everybody's doing scope one. And that's kind of what I usually tell most people at most businesses. How do I become more sustainable? How do I become more clean? Well, step one is electrify, right? Don't burn fossil fuels in your building. I know we had a question about scope three. Can either of you talk about scope three and what is the difficulty there? Why are things being so difficult?
I think number one, and then I'm going to pass the baton to you in a minute, but number one, these are very stratified. Your suppliers are geographically dispersed. They might be making one component. Much of the onus ends up falling on that end procurer. I don't know if that's the right term. The end party procuring these supplies to actually understand what the energy content is at the supplier stage. I heard a great anecdote a few weeks ago. I was at the Economist Sustainability Week in New York, and a large big box retailer, a CSO, was up on stage, and she said, well, it's really tough. We used to run these big symposiums, invite all our suppliers to come, and we'd educate them on greenhouse gas reduction. And at the first one of the suppliers walked up to her and said, "Great event, but I don't do anything with greenhouses, so it doesn't apply to me." So that's the starting point that some of these folks are facing when they're trying to get suppliers on board. Although I will say some of the digital technology is making it a little bit more frictionless for traditional industries to switch. And this is only going to get more difficult when you get into the traditional industries like commodities. So steel, cement, metals, these are very analog industries, and they don't have a lot of incentives to shut down production, rewire things. So if you're able to do something that is not disruptive, you can start to gather that data, track a little bit more effectively. I've got a great example of that coming into the chat. And if you've had a look at a few of these things, what's your perspective?
Yeah, so I think there's quite a lot of opportunity for software tools to improve various systems. So I think when we're thinking about where there might be a particular areas of growth, I think there are interesting areas when it comes to demand forecasting. So understanding renewable generation and better manage how energy is added onto the grid, and especially plan for peak demand periods. Other areas of opportunity include supporting market optimization. So different times that energy can be bought and sold to maximize profitability. And then also just when we're thinking about buildings, really optimizing HVAC systems, lighting, energy systems, and really automating and programming different tools so that energy efficiency can be optimized.
Yeah, great. That was a great transition to where I wanted to go was how are we using IT to work on sustainability? So this is great. This is perfect. So those were some really good examples. Do we have some other examples that are like for the electricity industry? Like what are, the electricity industry is basically the same as it was in like 1950, right? You have wires and you have transformers and you have substations. There's very little tech, right? It's just wires. How is IT having an impact there?
It's an excellent question, Lucas. And this is a really important moment for the technologies aiming at the grid for a few reasons. We've got to improve capacity, as we've covered pretty well, increasing demand, long interconnection queues, but also we can't ignore that there's increased weather threats from climate change. So there are some statistics out there showing utilities, some have really kept up with upgrades, but those upgrades are being offset by the damages and they're still experiencing downtime. So grid resilience it's an area we're starting to focus on a little bit more at Cleantech Group because it really hits at the intersection of efficiency, but also long-term sustainability in the face of weather events. But I'm going to back off a little bit here. Zainab, you've just kind of pulled up from a big deep dive on grid resilience. What were some of the key things that you found out during that?
Yeah, so we've mentioned quite a few different points here. And I think maybe where I want to start off is just some of the main challenges with grid resiliency, and that kind of comes down to outages. So there's been an increase in frequency of outages, but I think where solutions can kind of play a really major role is understanding how to reduce the frequency of these outages and how to improve faster response times so that there's a continuous flow of electricity on the grid into consumers. So one of the biggest causes of outages is due to the weather, as Anthony mentioned. We have a statistic from Climate Central that says between 2000 and 2023, 80% of all U.S. power outages were due to weather-related events. And throughout this time, in the latter half of the decade, so between 2014 and 2023, there were at least 2 times as many weather-related outages as the first 10 years. So you kind of have a doubling of effect in just the past decade. And that's really crucial because we need to understand how climate change is affecting grid resiliency. So there are a lot of software tools that can help understand these weather-related events. But what I think is also really interesting is understanding the innovation on the hardware side that allows us to gather more data points that we didn't necessarily have previously. So Lucas, you mentioned that, a lot of the electricity infrastructure has been pretty stagnant. Like you have technologies like transformers, circuit breakers that haven't really seen innovation in the past 100 years. But what I think is really interesting is you have these newer companies like Ampersand and Ionate who are really looking at transformers. And then you have another company called Blixit that's looking at smart circuit breakers. And I'll get into their technology a little bit, but I think the main takeaway for me is there's so much opportunity to gather new data points that we didn't have before. That will also open doors for other software developers to work with these companies or to develop their own companies and then partner with these new technologies. So just to get into it a little bit more, essentially, ionate and ampersand, as I mentioned earlier, they're looking at transformer technologies, and transformers are essentially the large boxes that change voltage as electricity moves through the grid. So you have solid state transformers like ampersand, and these are developing tools that better manage energy flow and have lower cooling requirements and take up less space. Similarly, Ionate is a company based out of the UK, and they're developing a hybrid intelligent transformer. So this minimizes energy losses, it increases transmission capacity, and it also has better control over the system. Another one that I mentioned is Blixit. So they're kind of looking at that circuit breaker technology space, and that's also been a space that's been relatively unchanged over the past multiple years. But they're also looking at making these systems more programmable and manipulating current digitally to provide faster response times. So this is really crucial because we need to have a reliable grid. Electricity is used to heat and cool homes, refrigerate food for restaurants, power hospitals, and other life-supporting equipment. So it's not necessarily a nice to have, it's a need to have in a lot of circumstances. But yeah, there's been a tremendous opportunity for innovators to work in this space. And I think there will be a lot of opportunities for more IT professionals and software developers to get into this space as well.
Right. I mean, it's my understanding that even at this time, there are very few sensors on the grid and very few switches, which is what I would consider smart grid, right, as a base to start on. And so once those are installed, we're going to need software to accept all this data and help make decisions and help make these switches act properly for these new power flows we're going to have, especially from unpredictable and variable renewables like wind and solar. So that's still an exciting field that's still yet to kind of explode, right?
Yeah, and now that you mentioned that, I feel there was one point I forgot to mention. So I mentioned the increasing number of weather events, but there's also the impacts of just rising temperatures as well. So you have technologies like advanced conductors. So there's this one company called TS Conductors, where not only are they improving the efficiency that these wires operate at higher temperatures, but they can also provide carbon fiber components that also allow for real-time data. So you have these kind of advantages on multiple fronts from these types of hardware companies that can also provide, like I mentioned earlier, more opportunity for data and real-time information to be collected as well.
Cool. I've been waiting. I know one of the issues has been it's hard to quantify the benefits of such expenditures because it's a regulated utility, so it has to have an argument for why the cost should be shouldered by ratepayers. I know that went through the same thing with smart meters, and I think there was a thought that they could use smart meters to kind of replace all that grid data because now you could get it at the end consumer. I don't know. Yeah, it's still just an exciting area. Like also with DER, so if you have a dispatchable generator in your facility, you also need information on, what the condition of the grid is. Is there strain on the grid? Should you turn on? What is the price you're going to get? All those data flows, I think, are starting to be defined. And so this is also a huge open space. You could have this to go the IoT angle. You could have it on your dishwasher. You could have it on your washer dryer. I'm still waiting for this energy IoT explosion to happen. So I don't know if you guys are seeing that. Is it just the large manufacturers that are doing this, or where is this going to come from? All this IT development, right?
Yeah, we're seeing it happen in a few places. Although, as you mentioned, it's always a challenge for utilities because they have to rate base a lot of the way that this is going to end up getting paid for. Excuse me. But the good news is sensors are getting cheaper, and the also data transmission is getting a little bit easier and cheaper as well. So a few that I'd point to, Zainab talked a little bit about monitoring lines, dynamic line rating. There's some great solutions that have pretty seamless implementation. That's at least going to cut down on the retrofit and installation cost, labor as well. Really cool one. I'll drop the link in the chat in a moment, called Heimdall Power. If you can envision it, it's essentially a spherical device the size of a baseball. and it just gets dropped onto a line, and it monitors it from there. And it sends it all to a cloud. And these actually get dropped in by drones. So you're really taking a lot of the safety issues out of the equation. You're saving a lot of time. So to answer your question, Lucas, I don't think it's categorically easy to deploy new technologies on the grid and get them paid for, but it's getting slightly cheaper and a little bit more frictionless. I'd take another example if you wanted really down to the meter and even indeed sub-meter monitoring. There's a great company called Prisma Photonics, and they're essentially running fiber optic cables along whatever assets you want and monitoring from there. That requires a little bit more installation, but the key here is you're not ripping anything out and installing something new. So it's a layered on upgrade, and I think we're going to need many more of these solutions to achieve the grid upgrades that we need for, of course, capacity improvements, but then also resilience against weather threats. It can't all go to a giant overhaul that's always years in the future. We're going to need to just be consistently layering on more technologies. And the digital cloud stuff gives a huge advantage in that you might be able to keep adding on new sensors, devices, taking in new data, and just enhancing your models along the way.
I don't know, Zana, you want to add on to that, or should we kind of pivot to generation maybe?
No, I think Anthony covered it.
Okay. I wonder if we could talk a little bit about generation and how that's changing. Of course, it's not even really generation, like storage, either grids on the wholesale grid side or on the distributed side, storage and its operation, these virtual power plants, which I understand to be solar array paired with a storage battery or things like this. Now, these are different than traditional generation. Is that going to cause a problem with the way we currently dispatch generation? Do we have to think differently about this? I know like storage is not just a generator, you also have to charge it, which also provides more complications. Does this fit into our current paradigm? Do we need new thinking about our grid and new, well, hopefully technology to make this all work better?
I think I can kick it off on the DER and virtual power plant side. I think the good news is that the more of these behind the meter type of technologies you have rolling out, the less you're going to need the grid upgrades, right? Because you're going to have more generation distributed, more capacity at homes, residences, etc. Taking a little bit of a step back for those in the audience who aren't familiar, a virtual power plant is essentially a system of, you think the dozens, hundreds of solar panels in your town probably now have, the newer ones have energy storage. Then if you're taking electric vehicles and you happen to have bidirectional charging, not super common at residences yet, but for fleets, it's becoming a little bit more common. A virtual power plant is essentially a software layer that's going to pull all of these together, and it's going to optimize when you're charging, discharging, and at its best, when it's most coordinated, it can act as a peaker plant might. Today, what happens is that during peak demand, usually going to be a gas-powered peaker plant, is going to fire up and it's going to deliver electricity when it's most needed and when there's a gap in generation. A virtual power plant would essentially allow you to circumvent that. Of course, you need customers to opt in, but assuming that's been done, you're able to then coalesce all of these devices and achieve the effect of a power plant. And there's some areas where it's already quite advanced, places like California, there's some good cases in Australia. And you've got innovation really at every corner of this concept of virtual power plants. You do have stuff that is in the distributed solar and energy storage. A few companies, name check here, Lunar Energy, Swell Energy, both companies that can tailor a solar storage EV charging solution for you, but also get you into a virtual power plant that best suits your needs. Another one that I think is interesting from a software perspective is a company called Leap. It's a very elegant solution. It's software only. It's device agnostic. Leap will market their software to hardware OEMs who then distribute the devices through utility programs or direct sales, however it might be. And then customers get into a virtual power plant through Leap's software that just kind of runs in the background. And this does a few things. It saves hardware vendors from needing to create this technology on their own. And it also helps utilities who are ultimately deploying the technology or recommending it to their customers, helps them to not get locked into a specific vendor by choosing a winner on their system. So a few things like this are developing, and it's allowing a lot more optionality for virtual power plants to start to take shape. Very much so, the software makes a difference here. You need that hardware endpoint to get somebody introduced into the virtual power plant. You've got to be able to optimize for the end customer. Great that you can offer value to utilities, but you've got to be able to show some tangible payback period on that initial investment. But we're seeing a dynamic where the software is really making a difference, and this is one of the key areas where we see companies trying to improve capabilities today.
Very cool. Very interesting. Yeah, it's my understanding that battery dispatch is still kind of an open question. So if there's any math people in the audience, that's certainly somewhere where you can get traction. I wonder if, Zainab, you can get into a little bit about different kind of generation technologies that are being developed. Also, a hot area, maybe some a little bit of nuclear. There's small modular. There's fusion. There's all sorts of excitement there. I don't know. Do you have anything for us on that?
Yeah, this has been a pretty big interest of mine. So it's very forward looking in some aspects. But I think when you think about fusion and fission, there's tremendous opportunity for an exceptional amount of baseload energy generation, and data and computer science and advances in computer engineering have played quite a large role. So just to take a step back a little bit, fusion is, when you're taking two smaller atoms and merging them together and releasing energy, and fission is more of the traditional nuclear that we have on the grid. So you have light water pressurized reactors that are taking larger atoms and splitting them apart to generate energy. So fusion has been considered the holy grail of energy systems for quite a while. And when it comes to bringing fusion power onto the grid, data tools like machine learning, predictive maintenance, enhanced simulation tools, these all accelerate the timeline and accuracy of costly physical experiments, which is why we've seen a lot of fusion industries hit temperature milestones and technological milestones quite rapidly in the past few years. So one point I wanted to mention is that AI and machine learning can be used to simulate conditions of reactors and virtually test components. And this is really important when you're thinking about really high temperature settings that are kind of difficult to manage physically, and you don't necessarily want to repeat experiments if you don't have to. So the ability to virtually test components, alloys, operational challenges, and understand safety challenges is really huge with these different simulation mechanisms. And so while many companies in these industries are using machine learning and artificial intelligence, there are a few interesting companies partnering with outside organizations that I wanted to call out. So the first one I wanted to mention are First Light Fusion and TAE technologies. So First Light Fusion has been partnering with a company called Machine Discovery, specifically using their AI-powered discovery platform. And this is specifically, as I mentioned earlier, for large-scale simulation studies. And then TAE Technologies has partnered with Google DeepMind, and they specifically co-developed AI to control plasma, which is a key aspect of just getting these fusion reactors up and running. And then when we come to the world of fission, so the small modular reactors, there's this company based out of New York called Radiant, and they're doing something really interesting. So they're co-developing their physical non-fueled reactor in parallel with a fully simulated software reactor. And that software simulated reactor will allow them to better understand how each component will react under fueled conditions. So you have pretty strong examples of how different data tools and advancements in software engineering are allowing these new types of baseload power to potentially be tested and move further along.
Oh, that's really cool. Finally, what digital twins are really for.
Yeah.
I hear so much about digital twins and nobody knows it's like. That's what it's for. You model your system and you accelerate innovation. That's fantastic. Yeah. Anthony, do you have some info on geothermal? I've been waiting for geothermal for decades. When are we going to have it?
Yeah, tough question. For those in the audience who are not so familiar with the geothermal dynamic, when you hear about geothermal, it's typically going to be in a volcanic region where there's big reservoirs of very hot water that are hot enough to then spin a steam turbine, generate electricity. The dynamic here, especially in the US, is that we have a lot of high temperatures, but it's in dry rock. So it's what they call the hot, dry rock. The challenge here is that there are a lot of instances of quote unquote dry drilling, where you drill and you don't actually hit that right area where you're able to harness that heat for energy. And this ends up being one of the most cost-intensive parts of the process. So there is a little bit now AI moving into this space. There's an interesting company called Zanscar, and they're what they call themselves an AI first developer. So they're going and using AI to identify these pockets of heat, optimize the drilling approach to reduce this risk of false starts, and again slice out that most costly part of the process. And you're seeing this happening in at an interesting time where there's a lot better hardware as well. The drilling technology is really taking off. You do see a little bit of corporate offtake of geothermal power as well. Google is one of the best examples. Have done a power purchase agreement with a company called Fervo Energy, who is doing hot, dry rock geothermal. So I don't have a perfect answer for you, Lucas, but it's at least becoming a little bit cheaper and a little bit more accessible to be going after the hot, dry rock. Not quite there yet. But I will note that since Cleantech Group does track investments in the space, Q1 of this year, I believe, was the biggest quarter we've ever seen in equity investments towards geothermal energy. So that's equity investments, venture capital towards the technology developers, and this was the biggest quarter we had seen. So people are starting to believe the message.
Well, that's good. Uh, I know I have seen some geothermal deployments. There's one in Hawaii. I think that was destroyed by that one volcanic eruption, but it was something like 60 kilowatts of generation. So it's been it's been very challenging, and yeah, it's always interesting to hear what kind of challenges they're reaching for. Um, I don't know if you guys wanted to continue talking about generation at all. You want to transition back to IT a little more? Everybody's good?
And we're happy to switch gears, I think.
Yeah, so I'm wondering if we could get back to this question of, okay, if I work in IT, like what can I do? Maybe a good place to look at is some new VC funding. So I've also seen a lot of VC funding recently on carbon credits and accounting. So that's maybe one interesting area. Maybe Anthony, do you have some more ideas there?
I think at a high level, when you read the media about a quote unquote venture capital drop off that happened in 2023, that certainly was the case, partially attributable to higher interest rates. When we look at how it happened in clean tech, there was, of course, a drop off, but it was less pronounced than in the wider tech environment. We had tracked, I can actually probably zoom in on the figure here. It had gone down to about 56 billion in VC investments in clean tech in 2023 versus about 75 in 2022. So a drop off, but I think what's important there is that 2023 still came out ahead of the pre-pandemic years. So what we're not seeing is that this was just a hype cycle that petered out. Of course, the high interest rate environment did impact things, but the space is growing. More companies are launching. I think Zainab will attest to the fact that we're seeing a lot more global innovation as well. Innovators coming out of really every corner of the world with promising solutions. So if I were in a traditional IT role today, the message I would take away from that is more companies are launching than ever in climate and clean tech, and they're growing too. Many of them are getting funded. Many of them are starting to even exit that equity financing continuum. We're seeing a lot more, especially in the energy and power space, locking in large debt rounds that allow them to move into real projects and manufacturing, which indicates a lot more viability of the business model. We're seeing this certainly in battery manufacturing. We see a lot more. We see a lot more companies who are able to enter into debt rounds after equity. We're seeing it in home electrification, as Zainab has mentioned earlier, heat pumps, and in other spaces like hydrogen too. So these spaces are strong, they're growing, and software is in there somewhere in all of them. We don't really look at AI as just being a software only solution. We have many companies that we consider still falling into that AI camp, to have a hardware component, and that may be their primary product, but some kind of software layer running through it. And it's increasingly becoming table stakes to be able to do both.
Yeah, I certainly see that a lot. Even in hardware companies, you have to have the software and it has to be connected, and everybody wants an online dashboard, right? Like you think about your fitness watch, same thing. It's a hardware company, but no, there's software on there and they want it connected with the grid and a dashboard. I want to see my heart rate, stuff like that. Yeah, yeah. Zainab, did you have any ideas also about software growth?
Yeah, I mean, I'm just thinking about coming back to the grid resiliency angle. You can kind of see how you need both software and hardware. So when you think about just like the increasing number of climate events, it's great that you can have all these monitoring solutions telling you that a storm is coming, a flood is happening, there's going to be a tornado, or that, a wildfire is happening. But at the same time, you kind of need the structure to be hardened to a point where, yes, you know all of this, but you also have either you've taken the physical steps you need to actually protect the grid as well. Whether that's adopting new hardware solutions or new wires or undergrounding, you kind of need both of those aspects. But that's not to say that, it's still really important to have those monitoring solutions so that you can better manage and design these systems as well. And I think just going back to some of your points earlier on like scope 1, 2, and 3 emissions, like there's so many opportunities across the board to just really gather more information and optimize solutions. So even when it comes to battery management, Anthony, like I think just like designing the batteries themselves, managing the batteries, and then even thinking about the markets, you can kind of use AI and software across that whole system. I mean, that's just one example, but you can think about buildings, other physical assets as well in that same kind of lens.
Yeah, that's a good way to put it. Yeah, I do know a great startup called Voltaic, and they specialize in battery testing for battery manufacturers, how to test it, make sure it works, make sure it's not going to fail, like in some embarrassing industries that had some bad battery failures that they had to fix. So lots of interesting data focused kind of angles to almost many parts of hardware, building it, operating it, um, end of life cycle. Yeah. Um, can we pivot just for a few minutes here and talk about what kind of talent do we need in to solve some of these challenges and develop some of these issues? What kind of training do people need? What kind of positions or education are people looking for in these startups and in these industries and in these businesses to tackle some of these problems? I think some of these are tough to define, and you end up having to have lots of skill sets, right? So I don't know if either of you have any insights on that. Learn as much as you can. Yeah.
Well, I think we're seeing a dynamic now where, of course, there's more software entering the space in the form of AI, and as I said before, even if that's a hardware company, the AI is becoming important. So you have an obvious one there of software engineering talent. Although I do feel like industry familiarity is becoming even more critical because we've gone beyond a space where many of these technologies are marketed just as, say, in especially green corporate or climate conscious consumers. These are becoming very practical products. If you think of all of the manufacturing technologies that are rolling out that are aimed at either reducing emissions altogether or electrifying, anything there that requires intimate industry familiarity. So I do think this is a time where people who might find themselves in traditional industries, might be mining, steel, cement, chemicals production, food and beverage production, that's very valuable to somebody developing a piece of hardware, software, or a software-enabled piece of hardware. So I see a lot of potential there that complements the software engineering talent that's starting to transfer into the space. I also think IoT sensing as well. If you consider what it takes to differentiate a business model in software or in I do think it's tough to differentiate on the middle part, which might be the sophisticated algorithms. Many of those do reside with the big tech companies. You can, however, differentiate if you're collecting data and using data that nobody else is. If you're finding a way to access something previously wasn't accessible, you might not need such a sophisticated algorithm. And then further downstream, as I just mentioned, having good industry familiarity, that does go a long way, because we are now really trying to decarbonize these hardest to abate sectors. And that does require good industry understanding. Zainab, any thoughts there?
Yeah, maybe just one point I want to add. So I think when we're thinking about home electrification, I think the customer is a little bit different. So if you're thinking about selling to an individual, if you have something like a smart thermostat, something like Nest or Tado, there's, I feel like, quite a bit of transferable skills from other industries where you just kind of need to sell a really great product. So I think any like software development and product development and marketing skills, there's quite a bit of transferability when you're thinking about who the customer is.
Might still be on mute, Lucas.
Okay, excellent. Yeah, I would also like to point out, I also teach in a certificate program called Clean Start at NYU. If anybody's interested, it does give you kind of some tools for approaching sustainable energy transition, and a little bit of industry expertise also you get from people like myself. I know I worked at Con Ed for about 9 years, and I probably spent the entire 9 years learning new information about the industry. And so this is true, I think, for all industries. Any product or service throws off data, has a unique business proposition or a unique value prop. This data ends up, in the cloud in a giant database, and these businesses are desperate to get value out of that data. At least Honeywell was. They had a mandate to put sensors on every product that they make, and to try and extract value from that data, which was my job at Honeywell. So it's a very exciting area. There's a lot of skills needed. So I really push continuous learning, continuous improvement. Every year you should be learning a new skill that makes you more impactful in getting value from this data. If it's okay, I'm going to switch to Q&A. We have a couple of questions I'm going to start out with. So maybe we can start with this one. How can tech help develop a sustainable mindset throughout all parts of a company? That's interesting. Maybe Anthony.
I think I'll let you lead this one, Zainab.
Yeah, I think this is an interesting topic. I think one of the key points when it comes to understanding, different data points is that if you are trying to optimize a system, you need to be able to measure it. So I think just understanding how you can kind of optimize every segment of a company or system, that kind of thinking kind of needs to be pulled throughout.
Yeah, I mean that's a good point. I mean, IT can develop tools that help everybody see what's going on as far as sustainability, as far as waste, as far as closed cycle thinking and mindset. So they can provide a tool set for that, right?
Mhm.
Yeah.
Mhm.
Unless Anthony wants to say something, I'm going to skip to the topic du jour. Right. How much energy does ChatGPT work? Is AI wasteful? How do we incentivize people? So I did look this up, and they did quote, the number I saw was, say per month, OpenAI has hundreds of millions of queries, and they consume about 1 gigawatt hour. So that's about a watt hour per query. So it's my understanding that the queries are not the problem; it's the training.
Right.
And so these models require, many months, sometimes years of training on a large number of GPUs that are just churning out energy like crazy. And there's some aspects of this model that may never even be used or queried against. So I think the training is where I would try and target less energy use in the AI industry, being smarter about the architecture of our AI models, thinking about what their function is, and not trying to create one of these 1000x models from an energy viewpoint. I don't know if Anthony, you wanted to add anything.
No, I mean, I'm really taking those statistics at face value. So I dropped a link earlier, and you'll have to scroll. I tried to post a photo in the chat, but I couldn't. If you scroll down, you'll see the estimates from Sustainable Metal Cloud. They had competed in some kind of, I don't know the proper noun, but some kind of data efficiency cup, and they won the award for energy efficiency. And they had essentially compared the different types of models and how much energy usage. And the number that I took out of it was about 1,000x again versus natural language processing, and something like 500x versus image detection, etc. Don't quote me on that. The numbers are in a nice little grid in that article. Spot on, Lucas. I think it's about the training. There absolutely is going to be something involved with the querying, but the training and the growth of these models, and the fact that it's just the big tech companies doing, for the most part, doing generative AI today, I would imagine that a middle market is going to emerge, and you're going to have other companies who are doing it. And that's probably where we potentially risk underestimating the impact, frankly, is right now we know of 5 or 6 companies using it. We're also seeing a few innovators starting to develop generative AI products. I'll give one example is a company called Citrine Systems, which is generative AI for materials discovery. Again, I would not be surprised to see an emergence of many more innovators and middle market companies. And that's where much of this data center planning, management, cooling side really needs to be considered.
Yeah. Interesting. A lot of innovation there. I know there are a lot of AI startups, and a lot of their funding is actually tokens to use GPUs on cloud. So you'll see Microsoft making some big number, $50 million investment in AI startup. And it's all just credits to use their GPUs on training. I mean, just tens of millions of dollars being spent on training these LLMs, I think is kind of crazy. And if you look at even like things like Microsoft Copilot, it's not one giant LLM. It uses other tools like internet search and maybe a calculator or some reason engine, and it combines it all together and feeds it to the LLM to just write it into an English form. So that's what I mean by kind of changing the architecture. Like, don't just make a bigger LLM, make an architecture that makes more sense, that's a little more energy efficient. And that's certainly a decision made by a software development, right, or a data scientist like myself. Another friend of mine also says, half the time you don't even want an LLM, you want semantic search. So you can look up semantic search, be like, wow, that is actually what I need. I'm just looking for the answer to this question, right? So, yeah, I think there's a lot of innovation possible in that whole AI architecture space.
I might add something to that, Lucas, and say our hypothesis, and it'll be years before whether it's borne out or not, is that of course there's a high energy content with the newest generation of AI, but if applied to the right problems, you could very much so see an offsetting effect in that we could achieve far more sustainability benefits than we do drawbacks. And that's probably, if I had to have any parting words with the group here, it's great to see more people transferring from maybe traditional software, social networks, SaaS products, enterprise SaaS into climate spaces. Really, what it's all about is starting to apply this technology to these challenging problems. And I might also mention, I mentioned earlier some investment statistics. Much of this is still targeted towards climate mitigation. We're now at an inflection point where we need to start innovating towards adaptation and resilience in addition to mitigation. So the surface area of opportunities is huge. And I think ultimately we should put every amount of effort possible into reducing the intensity, the energy intensity of AI, data centers, et cetera. But also we should be thinking, on the other hand, how do we apply these new models and new technologies to the most pressing issues?
Yeah, I agree. And with that, this has been fantastic. How can we reach out to you if we want to engage with Cleantech Group, Zainab and Anthony?
Yes, absolutely. Feel free to reach out at, drop it in the chat, research at cleantech.com, and I will drop a link to our company website as well.
All right. Cleantech.com is your website.
It is. That's one of the benefits of having coined the term way back when.
Awesome. Very jealous. Okay, Hannah, also, how do we get in touch with Tech in Motion or Motion Recruitment? Do you have a website or an email?
Yes, absolutely. We will drop the website in the chat, so feel free to check us out there and join the community if you're not already a part of it. You can also follow along on social for updates on all of our upcoming events. A huge thank you to you all for being here for today for this conversation and sharing such great insights. And thank you to our audience for tuning in. A recording of the session will be circulated via email, so if you missed anything, you'll have the opportunity to watch it back. Thank you all again, and we look forward to seeing you next time.
Thank you all.
Thank you very much.
Great. Thanks for having us.